In this unit of the course, we're going to introduce the idea of memory. A lot of the other material in this course is based on the idea of processes or the idea of threading. Now we're kind of changing gears a little bit to talk about how programs are actually going to be stored. So the first thing to do is introduce a little bit of background. So in general, we have a following model. We have a model where we have a CPU that contains some registers and then accesses programs or uses programs, right, also that might be in main system memory. So maybe I can have a little bit of a diagram even, right? I have, basically my CPU up here, right? CPU is implied to have registers, right? Maybe it has a cache as well. And then, right, that kind of connects to my main system memory, right? And things have to exist in one of these two places. Usually, right, the memory that's on the CPU, right, the cache, the registers, those things are going to be super fast. Well, the memory that's on the actual, in the RAM is just a little bit slower. Obviously, it's still fast, right? It's a lot faster than like a hard drive, but it is, slower than the stuff that's directly on the CPU die. And you can kind of picture that in your head, right? Obviously, it's going to take, it's kind of a farther distance, right, to travel between, the CPU's die, right, from one point to another point versus, from the CPU's die all the way to, a stick of memory on your motherboard, right? It's microns away, right, versus, inches away. So it's a huge difference there. So we have this basic model, right? We have main memory and then we have some registers, right? Usually, actually, if we want to make this maybe more generic, we can say that, there's maybe some sort of caching scheme in the middle, right? And that could be, some sort of an algorithm, right, that kind of takes care of that stuff kind of on its own. And so for now, we'll just focus on registers and then the main memory. So typically, right, when I go to run a program, right, for the first time, usually what happens, it gets loaded into RAM, right? So I have my program, P0 gets loaded into RAM. And then maybe once P0 is activated, what happens is it gets, basically migrated over, right? So it ends up, over here, on the CPU. And then maybe I'm done using it later on, and it gets migrated back to be, on the RAM. So it may go back and forth. So that's typically fine. And the cache, right, we'll end up talking about this stuff a little bit later in the course. But for now, I just kind of assume that there's some sort of intermediate step where we can, basically speed up those operations back and forth. Obviously, right, you have more main memory than you have CPU memory. CPU memory is faster though, so we kind of need to prioritize in some sense, what is it that I want to store on the CPU, right? And then when I don't need it, put it back in main system memory, right? When I do need it, bring it back. So you have a little bit of back and forth. Now, every single process that's running in my system, right, is going to exist somewhere. So I have here this diagram, right, from 0 up until, basically like a million something. I have different processes that are running, right? They're all running side by side. All of them will basically have this view of I'm in a virtual world, right? So from the point of view of RAM, this is how it's going to look, right? It's going to have operating system, process, and it's a blank space. From the process's view, right, all it sees is this, right? It's kind of like this little virtualized environment, and it sees that, it starts at 0 and it goes up until 500,000 or whatever this may be, right? This little delta here, right? So from the program's point of view, it just sees that stuff. From the outside, right, I have more RAM. That's the RAM everybody's sharing, and so in that case, right, that's going to be a higher number, right? And the overall OS knows that, but from the program's point of view, right, from the process's point of view, it just sees it from the inside, right? Just sees that little interval inside, and that allows you basically to have multiple processes. Now, inside of this, right, another thing we kind of record, right, is this idea of basically a base and a limit. So what the base is saying is this is where you start. Right? So every process has to start somewhere in memory, right? This is basically, where it's located. It has to have a limit, right? So that's, how much space starting from that base am I allowed to access? And so this is used for two things. First of all, it's basically for allocation. So if I want to have multiple processes running in my system, I'm going to have to basically write down its base and its limit, and I'm going to have to confine myself to acting between those two intervals, right? So I can basically say, I'm going to do stuff inside of here. I'm not allowed, outside of it. So it's a security thing. And then it's also so that I don't, do double allocation, right? So I don't end up allocating two processes over one another, right? That would be very bad because then people would both think that they have, access to the same memory when in fact they don't. So that would be a real big issue, right? People be overriding one another. So I'll have to kind of those two pieces of information. Now, basically from that, there's going to be some sort of a process, right? And we'll end up doing these kind of in more detail, and we'll do these kind of throughout this unit. These are basically diagrams that show kind of, the memory, access, process. And I won't really bother walking through this one. We'll do it more in the next video. Basically what it's showing is how do we go from having, our kind of a raw address, or something we'll call a logical address, and I'll introduce that in a minute, and from that being able to compute a physical address, right? So a logical address is an address that's seen by your program. A physical address is one that's actually good in terms of your physical memory. And we'll get there in a minute.